Okay, for number one, um, you guys actually have a different problem here. I just realized you have a 3 and a 9. I changed the problem for next semester, but that's what you guys have. So let's go ahead and put this in the correct format for graphing using transformations. And we're going to need to factor out on the inside of that function, we're going to need to factor out that 3 off of the x. And when you do that, you have x minus 3 left behind on the inside. Okay, so this 4 is going to move your graph up 4. This is going to move your graph to the right 3. This number, who is right next door to the x, is going to take your x value and divide it by 3. This number next to the y is going to change your y values and multiply all of your y values by 2. And when I say divide by 3 and times by 2, I'm talking about the x and y values in your parent table. So your parent table for x squared is going to go from negative 2 to 2. And then your y values are going to be 41014 on the original. Now these numbers are going to be changed. Your movement will be changed from your parent graphs, or your shape will be changed because all of your x values in the original table are going to be divided by 3, and all of your y values are going to be doubled. Okay, so looking back at the original table, this whole x column is going to be chopped into 3. So you get negative 2/3, negative 1/3. 0 divided by 3 is just 0, and 1/3, and then 2/3. I just divided each and every one of these x values in the original table by 3. All my y values are going to get doubled. So 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. And 4 times 2 is 8. I just doubled my y values from the original parent function table. And so this is the new table that you're working with. All the original x's from your parent functions table are going to be 1/3 as small, and all the y's will be doubled. And then you have to also remember or notice that there's a little negative sign here that I didn't talk about yet. And that's a vertical flip. Upside down over your x-axis, wherever you put your imaginary x-axis, you're going to reflect over that. Okay, so let's go ahead and start with our right 3 up 4. I'm going to be moving my origin, which normally starts at 0, 0, and I'm going to be moving it right 3 and then up 1, 2, 3, 4. If you do not like to put in an imaginary XY axis, then don't. If it bothers you, don't. I like to have the guide there. Maybe it's because I'm old or something. It just helps me count better and stay on track, make sure I'm at the right spot. Okay, so that's my new origin. That's my new pretend XY axis. And I already have my 0, 0 plotted. And then instead of plotting, there's 0, 0. And then instead of plotting 1, 1 from that point, I'm going to be plotting 1/3, 2, and making sure that I go upside down on the y. So instead of going over 1, I'm going to go over 1/3. And instead of down 2, I'm going to go, instead of down 1, I'm going to go down 2, I should say. Instead of over 1, over 1/3. Instead of down 1, down 2. And instead of 2, 4, over 2, down 4, I'm going to go over 2/3, down 8. So we have over 2/3 and down 4, 5, 6, 7, 8. That's a very skinny graph. And then I'm just going to match it up on the other side. I'm cheating. Back a third, down 2, back 2/3, and down 8. This is going to be interesting if I can actually connect these lines with my tablet. Hopefully you do a better job with the pencil. And there you have it, super skinny graph. It was vertically stretched and also horizontally shrunk, which makes it super, super skinny. All right, number 2, we need to get it in the right format because it's not in the right format. The parent function is the square root of x. What color did I just pick? Let's do that over. Okay, so we have y equals 1/2 the square root, and then I'm going to factor out a 4 off of that x, and I get x plus 2, and then we still have minus 3 on the outside. So I needed to factor out a 4 off the x to get it in the right format, and of course the 4 comes off the x and the 8. All right, so let's talk about the easy stuff. Do the easy stuff. That's a downshift of 3, and that's a left shift of 2. The 4 is going to affect the x, and it's going to do the opposite of multiplying by 4, which is divide by 4. The half is going to affect the y, and it's actually going to take your y's and chop them in half, divide them by 2. And there is no flip, which is good. That's to think about. The original ordered pairs for the square root of x go from 0 to 1 to 4, and that's it. And the y values are going to be 0, 1, and 2. And we do have some changes. We are going to take our x's and we're going to divide them by 4. And we are going to take our y values and half them. Multiplying by half is the same as dividing by 2. Okay, so x's are quarters, so we're going to have 0, 1/4, and 4 divided by 4 is 1. And the y's are going to be halved, so that's 0, 1/2, and 1. All right, let's move our origin 0, 0, and he is going to be a left 2 and down 1, 2, 3. And instead of going over 1, 1, we are now going to go over 1/4 and up a half. So instead of going over 1, we're going over a quarter, and instead of going up 1, we're going up a half. Alrighty, that one's done. So is that one. And then finally, instead of going over 4, up 2, we're going to be moving this much, which is over 1, up 1. And there you have it. Whoops, that's not so nice. Let's try that again. That looks not any better, but I think I just cannot do a good graph with this tablet. It's hard. And there we have it. It's as best as I can do, but at least the points are in the right spot. Okay, number 3. This is not your problem. This is the corrected version for next semester. What you guys see is that. So let's go ahead and handle this. Let's put it in the right format, which would be y equals 1/2. Let's factor off that 3, and you get x minus 3 cubed plus 2. All right. That's a shift up 2 units. That's a shift to the right 3. The 3 is going to take our x value and divide it by 3, and this 1/2 is going to affect your y value and divide your y's by 2. It's going to half those y's on your original table. And so the original table for cubed goes from -2 to 2. And then the original values, when you cube each of these numbers, you get -8, -1, 0. 1, and 8. And so now all of our x values you see are divided by 3. And all the y values that you see in this table are going to be halved. And this is what you should be thinking about mentally without having to write it down, but just so you guys can see it, see what I'm doing. Instead of just hearing me say it, I'm going to write down a new table. Okay, so that x value is going to be cut in 3, divided by 3. This y value is going to be chopped in half. This x value is cut into 3. That y value is cut in half. When you divide by 3 and divide by 2, you still get 0, 0. And then we're going to third that. And this guy right here is going to be halved. This guy is thirded. I don't even know if that's a word. I keep saying it. That guy is halved. Oops. Which gives you 4. And now we're ready to graph. And there is no flip on this, so I don't have to worry about going upside down, which makes it a little bit easier. Okay, let's go ahead and move to the right 3 and up 2. And if you don't want to put in or pretend to XY axis, you don't have to do that. I'm going to put in my new imaginary XY axis anyway. And then instead of going, I usually start with, well, first I start with 0, 0, which is already plotted when we move over 3 up 2. And then I'm going to start on the right side. So instead of going over 1 up 1, I'm going to go over a third and then up a half. And instead of going over 2 up 8, I'm going to go over 2/3 up 4. So estimate 2/3 and count up 4. And then once you get those 2 points plotted, you can just use a little symmetry and match it up on the other side. But I'm going to do it point by point off the table here. So instead of going left 1, down 1, I'm going to go left a third and down a half. So left a third and down a half. And then instead of going left 2, oops, up here, left 2, down 8, I'm going to go left 2/3 and down 4. So left 2/3, estimate it down 1, 2, 3, 4. And then this is going to be interesting as usual as I try very carefully with this pen tablet sketch that graph in. Alrighty, let's go ahead and get this guy in the right format. Number 4, we're going to have to, on the inside of your function, factor off that -2 off the x. And when you do that, you get x plus 1. And I'll just quick mental math that if I distribute that through, do I get -2x minus 2? And I do, so that's good. This is going to move my graph down, and this is going to move my graph to the left. So down 4 to the left 1. The 2 that is right next to the x is going to take your x values and divide them by 2. And the 2 that's on the outside is going to take your y value and double it. And then I have 2 reflections. Not only am I going to flip my graph upside down, but I'm going to flip it sideways as well, and it's going to reflect over both the x and the y axis. Okay, so let's go ahead and look at the parent graph. We haven't seen this too much with the problems that you were getting for homework. So our x values go from -8 up to 8, so -8, -1, then 0, then 1, and then 8. And then when you cube root -8, you get -2. When you cube root -1, you get -1, and then we get 0, 1, and then 2. And let's go ahead and change those values in our XY table. This is a pretty tough graph. So I'm going to take my x value and I'm going to divide it by 2. And then I'm going to take my y values and I'm going to double those. And I'll show you, like, I guess 2 ways to do this. But anyway, we're going to half all our x's, so you get -4, -1/2, 0, 1/2, and half of 8 is 4. And then we're doubling all our y values, so you get -4, -2, and 0 doubled is 0, 1 doubled is 2, and 2 doubled is 4. Okay, so let's go ahead and graph this using our new table. Okay, so the first thing I'm going to do is graph my new origin, and I'm going to move him left 1 and down 4. So we're going left 1 and down 4 and putting a dot. And then my new XY axis. I'm going to put that in. You don't have to if you don't like it. I have a lot of reflecting to do in here. Okay, so this graph is kind of special. It normally looks like this. And what happens is when you have a double reflection on this graph, it's going to look exactly like what it started. All the ordered pairs that are in this lower quadrant right here are going to end up in the top right, and all the ordered pairs that are in the top right are going to end up down in the bottom left. And so this double reflection on this graph makes it look exactly like what it's supposed to originally in the parent graph. So I'll show you on the ordered pairs. If I am going to reflect over the y-axis, which is this negative right here, what that technically does is flip all my y. So that becomes plus, plus, minus, minus. And the negative that's on the inside is going to reflect my x's over the y-axis. So that flips all the signs of your x's. And then this set of ordered pairs down here a couple seconds ago was actually up top, and that set of ordered pairs was down below. So none of the actual spots that you're plotting are going to really change. You literally are going to have all the same ordered pairs graphed, just in a different order. Okay, so let's go ahead and plot this guy right here. And I already have all the signs changed. I don't have to mental math my reflecting. I'm just going to go ahead and use what I have there. So you're going to have a point back a half and then down 2. And then you're going to have a point back 4, 1, 2, 3, 4, and down 1, 2, 3, 4. And then you're going to be, that was that one. And then you're going to be over a half and up 2 from your new origin, and then 4, 4. 2, 3, 4, 1, 2, 3, 4. So you can see that the shape that you get when you have a double reflection on both the x and the y axis, you reflect x and y on a cubed root, the graph looks like the regular graph. And that also happens with x cubed as well. It does the same exact thing.